Lecture number 11, we're going to take a look at the mammary glands here as well. Some of this information has already been covered over on the anatomy side as well. The mammary glands, of course, produce breast milk, and so they do take up some of the space inside each woman's breast. And they're actually, interestingly enough, modified sweat glands that produce milk instead of sweat. They're divided up into 15 to 25 lobes or sections that are involved in milk production. Some other features, the nipple, of course, is the opening through which the milk comes out. The areola is the darkened, pigmented skin around the nipple. Each breast does have suspensory ligaments, dense connective tissues that help attach the breast to the underlying muscle as well. The lobes of the mammary glands are divided up into lobules, lobule meaning a tiny lobe, and there you have alveoli, roundish-shaped structures, shaped in a similar way to the ones that you find in the lungs, and they produce milk. Okay, so here is a diagram of a mammary gland over here. And so you can see the yellowish tissue, of course, those are the fatty tissues within the breast. And each of these larger brown structures is a lobe. And then those are divided up into lobules, smaller sections where you have these rounded areas of alveoli. And there are cells along the inside lining there that produce milk. And then there also are smooth muscle tissues that surround those alveoli that contract to squeeze the milk forward into the ducts that will carry it down to the nipple. So you may remember talking about some of that at the beginning of the semester when we covered endocrine. We mentioned that good old oxytocin, if you remember, produced by the posterior pituitary. One of its jobs is to tell the smooth muscle cells that surround these alveoli in the mammary glands to contract, and that squeezes milk forward. And then there's another hormone, prolactin, that's produced by the anterior pituitary, and it signals the milk-producing cells within these mammary glands to actually produce the breast milk. So you've got those two hormones that are involved in lactation, which is the production and secretion of the breast milk. The pathway of milk, it's produced within these alveolar structures, these alveoli and the lobules, and then it gets squeezed forward into lactiferous ducts, which lead to, if you notice on the diagram here, you've got these widened areas, various lactiferous ducts that are coming out of each lobe drain into lactiferous sinuses. And those are larger compartments where milk is stored. And then you have a short continuation of the lactiferous ducts to the nipple. And so as an infant is nursing, that is going to, of course, they're going to be sucking the milk down that short duct from the sinus and through the nipple. You may remember from earlier in the semester talking about how the nursing action on the nipple from an infant stimulates, through nervous system detection and signaling, stimulates oxytocin release out of the hypothalamus and into the posterior pituitary. And then oxytocin will travel down to the mammary glands and tell the smooth muscle there to contract and squeeze more milk forward to the nursing infant. And oxytocin also, you may remember, stimulates uterine contractions. It's needed during labor, which we'll cover more of at the end of the unit. And so that's why nursing females will sometimes experience uterine contractions, because that same hormone oxytocin that's supposed to be squeezing more milk forward stimulates the uterus to contract as well. All right, a very important homeostatic imbalance of the breast, of course, is breast cancer. This is the second most common cause of cancer death in the United States and U.S. women. Um, Invasive breast cancer is the most common type of malignancy where a cancer is spreading from one tissue into another. Because again, it's not that the cancer in the breast is the life-threatening problem. It's when those cells migrate out of the breast and take up residence in other tissues. That's what becomes life-threatening for the female. 13% of U.S. women will develop breast cancer during their lifetime. And it develops in these cells within the mammary glands. Those are epithelial tissues, and epithelial tissues are generally the most prone to becoming cancerous. Treatments that are available, you have no doubt heard of a radical mastectomy, where an entire breast is removed, even the underlying muscle, the fascia, the connective tissues associated with the muscle, and also lymph nodes. So the idea there is if any of the breast cancer cells have migrated out of the mammary glands and into the underlying muscle or have gotten into the lymphatic vessels and the nearby lymph nodes, hopefully those cells will all be removed through the radical mastectomy before they can spread elsewhere in the body. In an earlier stage of breast cancer, where all the cancer cells may be together in one tumor, a female may elect to undergo a lumpectomy, where only the cancerous tissues are removed. And then there's another procedure called a simple mastectomy, where only the breast tissue is removed, so you don't remove the underlying muscle and fascia and so forth. And sometimes axillary lymph nodes, those are the regional lymph nodes that drain lymph fluids that are draining off of the breast, lead to axillary lymph nodes. So if any breast cancer cells get into those lymphatic vessels that are draining the breast tissues, that's where they're going to go first. They're going to wind up in the axillary lymph nodes. So that's a good place. If you remove those, a pretty good chance you're going to remove those cancer cells as well. And then some women do elect to have breast reconstruction, have implants put in to replace the breast or breasts that have been removed. All right, that was kind of a quick overview on mammary glands, breast function, and lecture number 12, we're going to start hitting some of the gory details of oogenesis, development of the egg cells in female. That's going to lead to a discussion of the hormones that get involved in controlling and regulating these processes. So we'll pick up there with lecture number 12.